Hi ho. Demoing a software that I've been working on, which is based on the Microsoft Kinect, um, the green screen demo that came with the Microsoft Kinect SDK. And it's quite an interesting demo because I feel that you could use that kind of a demo to demonstrate your work or to present your work maybe at a conference you're not able to attend or at a presentation you're not able to be there. So I did some work on it to change it so that you can load any background image you want, and you can also load any background image you want, but you can also load any video that you want. So right now, what I've done is I've converted my PowerPoint file to a video, and then I'm going to try and present it to you so that you can see what it can do. But one of the interesting things that I noticed that that you could possibly do is to have a um, not just the video being pre-recorded, but you can have a situation where you have the video playing live like I'm doing now on my application, but have Skype running concurrently and actually share that application through Skype. So share my desktop, a section of my desktop through Skype, and people can see my presentation live, ask me questions, and it will feel like I'm actually there answering their questions. So it's quite a neat demo in that respect. So what I'm going to quickly do is to open up the presentation for you. Right. So you just press play, just open it, press play, then I pause it because it's only pre-recorded for to stay up for at least I think about 5 seconds. This is a presentation that I did at a Kai conference. It's a work that we did, quite interesting work. And I'm just trying to show you really how it will work. And you can kind of tell, you can see some artifacts that are coming up here. This is because it's not able to get the tracking perfect sometimes. So these are some things that, one just has to work on to perfect over time. So without wasting too much time and I'm not going to try and present everything for you, as I did at the conference, but basically just give you an idea, really. So those are the aims. Clearly, if I'm going to present to you, I should tell you what the presentation is about. We have a project which we call beaming, as you can see here, called beaming. And what we do is we take a person from this capture site A, and we call them a visitor, and we beam them or transmit their actions into something at the destination. That something could be a robot or it could be a display. Now the part I'm working on is this part, which is this spherical display here. You get to see a video that shows that in a moment. Right. So this is a setup that we've been using. Uh, one of the setups that we did. This is what I'm trying to show you, because what we've got here is what I call the avatar fat head. Because it's a fat head, it's not how our head looks, but it takes up the whole space of the spherical display. And this is the setup that we did for one of our demos in that project. So moving on, there's been some previous work. If you want to find out more about this previous work, please feel free to visit my website. But what I'm just trying to simply do, visit my website, you can download the paper. But what I'm just trying to do right now is to show you the display mode and things like that. In this case, we've got the avatar head, which takes the whole shape of the spherical display, and then we've got this, which looks how a normal head would look. So it feels like if the head is actually within the display, but actually all it is, it's actually just in front of the display. And then we've got the same setup here, but the movement of the head, the way it rotates along the surface of the display. And I'll show you a video in a moment. Right, so again, this is how it works. I'm not going to go through the technical setup. You can read my paper for that. So basically, we conducted an experiment to test these three methods. So what we had was a spherical display, balls in the middle, and then the participants sitting at three different positions here. So as you can see from the presentation, the video that I'm showing you here, you can see how the head moves. when it's looking at a ball. So it will shout something like target one, and then you will look at where target one is, and the participant will list where that target is in the picture. So what we're trying to find out there is how do people perceive, how would someone perceive the direction? The balls are closely spaced, so you can see how it's possible for somebody to make an error and not be able to judge correctly where the ball is. And so that kind of gives you an idea of what the experiment is trying to test. The perception of, head and eye gaze, really. You know, because the shape of the head is different from how a normal head would look. We're wondering, if people perceive it the same. So compared to what a normal head will look like in that display, which you can see there, where the avatar head is looking upwards initially, now looking back at the center, and then look at somewhere at the bottom, as you can see. So that's the second display mode that we tested. Because we had to test it because this is the actual shape of an avatar head. And then we had the third one, which is what we call the surface mode, which what happens, if you look clearly, you can see that it's moving along the surface of the sphere and just move to this side. So you can see, yeah, and then it moves back. Exactly. So this is the kind of setup that we were testing. So we were testing between three modes in order to find out whether users can still judge and how quickly they can judge these different three modes. And what we found, if I just pause this page, then move very fast, what we found is that they could interpret the direction of the normal and the inflated modes as accurately as each other, but they were both better than the surface mode. I guess in a way this was really expected, but what we can't say for certain that we would have expected was that the fat head would be interpreted in the same way. We felt that because it was an avatar head that was taking up the whole sphere, people might not be able to interpret it because of the way it looks. They might be so carried away with the look and feel of that avatar head that they misjudge the direction incompletely. But what we found was that they judged it as accurately as the normal mode. So if I just press play, move on. Again, something I should talk about is work that was done that was similar in a way to someone called Wilson and others in 2000. They were looking for what in the human face actually determines gaze perception, head and gaze perception. And what they wanted to see was, is it the surface of the head or is it the features within the head? So they dissociated it by having a head here, a face here, and the internal features here. So what they wanted to see was what exactly is affecting um, how people perceive gaze, really. And what they found out was that regardless of whether it's the surface, whether it's the head shape or whether it's the features, people were able to discern head orientation properly, which kind of was similar to what we were saying, because here is likewise in our findings, there was no difference in accuracy between the inflated modes, which lacks defined outline, head contour, and the this normal mode and the soft and the normal mode, which has defined internal features and head contour. So we found clearly we found the same similar findings. So we kind of justify that, make that paper kind of interesting. So that kind of summarizes what we were trying to say here, which is that you can have a spherical display system. It's a fun place and capture someone's head movement. As you can see, we also are able to capture facial features using the Kinect and basically just display that head movement, facial features, and display it remotely. One thing we can do, what we currently do is it's just static because it's a big and heavy, spherical display. But we could mount it on a robot. It's something we are considering doing. Um, and you could mount it on a robot and have it walking around. That could be quite interesting when you have a fat avatar head walking in your face and asking you, "Hello, how you doing?" You know. In any case, we then so this is the bit that wasn't properly recorded when I was converting the PowerPoint file. Basically, what's happening there, what was meant to be happening there was, as my colleague there moved his face, then the, the avatars on the spherical display also move their face, which means that we can transmit that kind of information over the internet remotely as well. So not just transmit the audio, we can transmit the facial features, we can transmit almost everything. And as we just found out, the gaze perception is the same. It's quite accurate as well, and it's quite high, so which is quite interesting. And we can transmit that as well. Another work we have been doing more recently is we've been working on the video. A colleague of mine, Tanya, been working on the video displays. So instead of using avatars, we're now mainly working on video because you can just capture videos and just display that instead. So we use all sorts of interesting methods, and we have papers on it now that you can also download along with these papers. Have a look if you're quite interested. But if you're just looking at this because of the demo that I'm trying to show, also tell me what you think of it. Tell me, you can see some glitches, you can see some things that I had to do in order to make it work, like the microphone that is just simply sitting in my pocket. This is because I don't have a very good microphone setup here. Um, the fact that I'm looking at the presentation which screen which is here, but my Kinect which is there where the camera is. So again, that's simple. I could put the camera on top of my presentation screen to make it as close to where I'm looking at as possible. But then I also do have to adapt my behavior. So if I'm trying to pretend like I'm presenting to an audience, I could stand and be looking, you know, in different directions just to pretend like oh, guess what? I'm pretending I'm talking to an audience. And you can kind of feel like you're talking to me as well. So there are different methods one could test it. I'm hoping to um, hopefully run an experiment maybe next. So I'll be more than happy to take your comments, let me know what you think of it, how it could be used. But I do think it's quite an interesting demo, which is why I did some extra work. We need to make some improvements. This wasn't exactly how it came. You might find that if you're a person with lots of hair, like my friend there, for example, the Kinect is not going to be able to track as good as tracking me right now because I've got a defined, not a lot of hair, the Kinect is able to get the feedback it needs in order to reconstruct all my edges um, in the video. And that kind of sums up everything I've got to say. Thank you for listening. Uh, I definitely want to hear your comments. And um, there's more work that I was explaining earlier, and that's being shown right now. Definitely want to hear your comments. Please do contact me if you want to try out the software, and I hope that you find it interesting. I'm not releasing any source code yet, unfortunately, but I would give you a copy of the software.